variable with all lowercase is different from a variable with a and v in uppercase, and that is different from a variable. So these are all different variables with different values. Just be aware of that while creating variables. So here are some valid legal variable names, and below what you can see here, these are some invalid variables that I've created. So here we have a space that causes a problem. Here we have a special character that causes a problem. Here we have the hyphen. Python actually reads this as a minus. It tries to subtract these three variables, but they don't exist, and that's why there's an issue. And finally, here we are trying to use a number as the starting. You cannot start a variable with a number. So that's all we wanted to talk about variables. It's a very simple concept. Python makes it really easy to use them. And at this point, what we'll do from now on is after every section, just record our work. So I'm just installing the Jovian library and I'm running jovian.commit. So that's committed now. Any data that you store inside a Python variable has a type. So far we've been working mainly with numbers, but there is a lot of different types of data that you can store within a Python variable. And a variable's type can be checked using the type function. For instance, a variable has the value 23 and its type, if you use the type function, its type is int. Int stands for integer. Similarly, is today Saturday? It's false. Its type is bool. It stands for boolean. My favorite car is some text and its type is str, which stands for string. And finally, the Three Musketeers, it looked like it was like a list of three strings. So it has the type list. And Python has several built-in data types for storing different types of information into variables. What we will look at are some of the most commonly used data types. Now there are a few primitive data types: integers, floats, booleans, none, and string. And then you have these other types like list, tuple, dictionary, and then you have sets and classes and so on. These are called data structures or containers because they hold multiple pieces of data together. And each piece of data then has its own type. That's a key distinction. So let's start by looking at integers then. We've been working with them. We know what they are. They represent positive or negative whole numbers. So from negative infinity to infinity. Only thing to note is that they should not include any decimal points. So here's an integer and it has the type int, as we've already seen. Now, unlike other programming languages like C+ and Java, where you may have different types of integers, there is no such limitations on what is the lowest or highest value an integer can hold. In Python, all integers are arbitrarily large, right? So here you see a large negative number. It is quite arbitrarily large and it still has the type int, and that's integers, pretty straightforward. Then we have floats or floating point numbers. So these are basically numbers with a decimal point. Again, there is no limit on the value of the float, although what will happen is some kind of approximation might happen depending on how many decimals you put in. So they are a little bit limited compared to integers for sure. So here I'm looking at the value of pi, the mathematical constant. I put in 3.14 and so on, and then I can check its value. And you can see here that it actually truncated the value around 15 or 20 decimals. So there is a limitation in floats there. And then if you check the type of pi, that turns out to be a float. And one important distinction here that we often tend to miss is that even a whole number is treated as a float if it is written with a decimal point. For instance, here we have a number which I've written as 3.0. That's a float because there's a decimal there. And similarly, even if I do not have something after the decimal, even if there's just a decimal, that is also treated as a float. So just know that sometimes that trips people up a little bit. And then there's another way to write floating point numbers. Let's say you have a very small number with 0.5 zeros and then a 1. The way you can write that, let's say if you want to do 0.000001, you do 1e minus 5. So that e minus 5 basically gets converted to 10 raised to the power minus 5, and that gets multiplied with this number. But I'll just do 1e minus 2. And you can see it has the value 0.01. Here's another one. Here I'm using a positive exponent. So here this is the Avogadro number. So here 6.022 times 10 to the power 23. And there you go. So that is the Avogadro number. That's pretty much it about floats. Again, pretty straightforward. And floats can be converted to integers and vice versa. So the way to do it is using the float and int functions. So the types that we see, these are actually functions that you can use. So the float function, if you pass it an integer, let's say float current year, or it had the value 2020. So now that becomes 2020.0, or float times a large negative number. Let's see what that value is. So what I'm doing here is I am actually going to insert a code cell. The way I could do it is say insert and insert cell below, or I can simply just press escape plus B and that will insert a code cell. Okay. So let's just type the name of a variable. And again, what you saw here was that I simply typed a_l and then I press the tab character, the tab key, and that automatically completes to a variable name. So that's one nice thing about Jupyter. So you see here, it's a large negative number. We can convert it into a float. So when you convert it into a float, some precision is lost, but now you can see that it's written in scientific notation. Similarly, we can convert the value pi to integer. So pi was 3.14. When you convert a float into an integer, the part after the decimal gets removed. So even if you're at 1.99 and you convert it to int, that gives you back 1. So that can be a little unexpected sometimes. And finally here we are taking the Avogadro number and converting it into integer. When we perform arithmetic operations, what happens is if all the operations are integers, generally speaking, the result is also an integer. But if any of the numbers that you're operating upon is a float, then the result gets converted into a float. So for instance, 45 times 3.0 is a float, but 45 times 3 is an int. Now one exception is the division operator. The division operator always returns a float because there's no way to know in advance whether there is going to be a decimal point or not. So just to be consistent, it always returns a float, whether it's 3.33 or whether it's 5.0. And if you want to get back an integer, you simply use the double division. This is also called the integer division operator, and that returns an integer. Okay, so that's floats, pretty straightforward. Then we have booleans. We've already seen these. Booleans are the results of conditions. Essentially, the boolean type has exactly two values, true and false. There's no other value there. Floats, there are unlimited. Integers, there are unlimited. But booleans are just these. And booleans have the type bool. So here I'm setting is today Sunday to true. Then I just check the type. This should say is today Sunday. Yeah. Just check the type of is today Sunday, and that turns out to be a bool. That's how you declare a boolean. It could also have been a condition. So let's say this could have been 2 less than 3 and it is still true. Let me revert that. And booleans are generally returned as a result of a comparison operator. So for instance, here I have the cost of an ice bag is 1.25 and I have the comparison whether it's greater than 10. So now the result, the variable is ice bag expensive, is holding a boolean value. You can check that with the type. And an interesting thing is that booleans are automatically converted to integers when they are used in arithmetic operations. True gets converted to 1 and false gets converted to 0. So it's useful that if you have a bunch of booleans and then you want to just add them together to just see how many trues there are or how many falses there are, you can simply add them as integers. So if I do 5 plus false, 5 gets converted into the integer 0. So we end up with 5. And if I do 3 plus true, and here I'm doing 3 dot. So first true gets converted to the integer 1. Then since you're adding an integer and a float, that gets converted into a float and you end up with a float 4.0. So that's something to keep in mind. Another very useful thing is that any value in Python can be converted to a boolean using the bool function. So you just use the bool function, put in anything that you write in Python, any value or any expression, technically speaking, that expression will get converted into a boolean. Now, when it gets converted into a boolean, how does Python decide whether it should be a true or a false? There is only a limited number of things that become false. So the value false itself is false, and then all the empty states of the different data types, they get converted to false as well. So you have the integer 0 that gets converted to false. You have the float 0.0 is false. Then the empty value none, we will see it, that gets converted to false. The empty text, the empty list, the empty tuple, empty dictionary, empty set and range. So all of these get converted to false automatically. And we will see how this is useful later when we learn about if statements. These are some examples of false, and then here these are other examples of values that are converted to true. So these are called, the values that become false are often called falsy values, and the values that become true are often called truthy values. So it's also called falsiness of those values. So that's booleans. Next we have the none type. The none type has a single value called none, and it is used to indicate the absence of a value, right? If you want to declare a variable, let's say, which may be assigned some value later on, or because of some reason you want to indicate that a value is missing, but you still have to, let's say, set a variable, then you can simply set it to none. This is nice to have that type so that you don't have to use 0 as a fill-in or use false as a fill-in, which you have to do in other languages. So you just say variable name equals none, and that sets it to none, and it has the type. Nothing much going on there. Finally, the last primitive data type is a string. So a string is used to represent text in Python. Why is it called string? You can think of it like a string of characters tied together with a string, a sequence of characters. And strings in Python must be surrounded using quotations, and you can use either the single quote or the double quote. And strings have the type string, string. So here let's create a string today, and it has the type str. Oops, I guess this is an error. This should just say str. You can use either single quotes or double quotes to create a string. What might happen is that the text that you want to write itself may have single or double quotes, so just be careful about that. Now, if you're creating a string with a single quote and there is a single quote inside, for instance, one flew over the cuckoo's nest. Now what happens here is the string ends here, and then Python starts to execute this as proper Python code, and then it's going to show you an error. Okay, it says invalid syntax. So this is where what you might want to do. One technique is to just add a slash. This is the other slash that is above your enter or return key. So just add a slash. What it does is this escapes the next character so that it is not treated as a closing quotation mark. Okay, and the slash won't show up when you actually print it. That is one way to check it. So you can see here it says one flew over the cuckoo's nest. So we have escaped the quote. The other way is to simply use double quotations when you have single quotations in your string, and single quotations when you have double quotations in your string. And there are some more examples here. I will let you play with these. Now you may have a lot of questions. What happens if I have both double and single quotes? What happens if I have to break my string into multiple lines? I can't fit it on a line. All these things, Jupyter is a great way to try them out. The way you should try it is first try something, try what you think might be the solution, and run it, and then get an error, and then maybe look up online, or maybe just take the error and Google it, or maybe just post that error on the forum, and then somebody answers it, and then you will learn how to actually do it. And once you do that, you will retain it better. So there are some examples of different types of strings. You can also create strings that span multiple lines. So for instance, here, this is a string that goes over 4 or 5 lines. The way to do that is to use 3 quotations. 3 quotations is a special marker in Python. That's our multi-line string, and you can experiment with these parts. I'm going to leave it up to you. But what's interesting is now already with string, even though it's a primary data type, it actually does contain a bunch of characters. So it's a container as well. You can actually check the length of a string using the len function. You can check how many characters it contains. For instance, length of my favorite movie, One Flew Over the Cuckoo's Nest, is 31. And then there are some special characters. So for instance, the /n character represents a new line, and then there are escaped characters. So these special characters or escaped characters are actually counted as a single character. So for instance, here I have a multi-line string where I start the string, then I have a, and then I have a enter. So now this enter is actually a character in Python, because Python stores the enter or the new line as a character. This is the /n character. Then we have b. So in total, there are 3 characters here. And you can see that sometimes it gets printed like this. So we have a, and then we have /n, and then we have b. And if you check the length, that turns out to be 3. So that's good. We know how to check the length of a string. If you want to actually take the string and then convert it into a list, so a list is a different data type that we will see soon. If you want to convert it into a list, you can just pass it into the list function. And now that gives you a list of all the characters, all treated separately. If you want to access individual characters in a string, you can do that as well. So today I have set to Saturday. And the way to access characters is to type the name of the variable and then type a square bracket, and inside the square bracket use an index. So the characters are indexed from 0 to n-1, where n is the length of the string. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or I think this goes up to 7. So 0 is S, today 3 is 0, 1, 2, 3, U, and then today 7 is the last character. And you can also access a part of the string by providing a start index and an end index. So for instance, we are saying 5 to 8 here. So we go from 0, 1, 2, 3, 4, 5. So that's D, 6, 7. And then the last index is actually not taken. So we do not use the last index. So we go from 5, 6, 7 and skip 8. That's just how ranges work in Python. That's how you get something out of a string. You can also check whether something is in a string. You can check whether a string contains something using the in operator. We can check day in today, that's true. We can check sun in today, that's false because today it says Saturday. So that's how you check whether a string contains a piece of text or not. Then you can join strings or concatenate them using the plus operator. So for instance, here we have a full name, Derek O'Brien, and then we have a greeting. So if you do greeting plus full name, these two strings will get joined. And this is a very common thing we do. We spend a lot of time working with strings in Python and combining strings to format different messages. Now, one common thing that you might miss is that if you forget to give a space, because Derek O'Brien ends with an N and then here it starts with a hello. So if you just use a plus symbol, then here you might run into issues where this becomes a single long word called hello Derek, and you probably don't want that. So that's why what you want to do is you want to have a string here in between, which is a space. Then you have the full name. And then if you want to add something at the end, you might do that as well. So you can add many strings together. Strings in Python have many built-in methods, and these methods can be used to manipulate these strings. So we've looked at certain functions. So there's something called the print function, and then we looked at functions associated with data types. So similar to functions, there are these methods which are also functions, but they are associated with specific data types, and they are accessed using the dot notation. So any methods that are associated with strings can be accessed by taking the variable name of the string or taking an actual string and then using a dot and then calling the method. So in some sense, what this does is that lower is no longer a function that is globally defined. Only certain data types have the lower method. In fact, only strings have the lower method. So on strings, you can call the lower method by calling today.lower. And this lower method automatically gets access to the string that you are calling it on. So it has access to the value of today and it performs a certain operation, and in a lot of cases it can return a certain result. So for instance, when we do today.lower, what happens is today was Saturday with a capital S, that becomes Saturday with a lowercase s. So we looked at the lowercase method, which takes the string and converts it into lowercase. Then we have an uppercase method. So we do Saturday.upper, and that takes a string and converts it into uppercase. And then there is another function called capitalize. This takes Monday and returns this. These are pretty simple methods, but there are also some really powerful methods that we use all the time. So one is the replace method. So in the replace method, what we're going to say is we're going to take Saturday, the string, and then we're going to call replace and then give it a couple of inputs. So we want to give it the input, what do we want to replace? So let's say we want to replace Saturday, and what do we want to replace it with? So let's say we want to replace it with Wednesday, and that makes Saturday Wednesday, right? So this is something that you might do from time to time within a string. But do note that any string methods, and this is unique to strings, any string methods will always return a new string. They will not modify the original string. So for instance, even though another day has the value Wednesday and today still has the value Saturday. And this is a key thing to watch out, whether methods modify the existing object or they return a new object. And we'll see with lists how that is different. Another one is a split method. I will let you check this out. The split method is pretty useful. There is one more called the strip method. The strip method can remove spaces from the beginning and the end of a string, not from the middle. That is also pretty useful. It can remove white space characters. It can remove new line characters. So these two are pretty useful when we are reading in data from a file. And we will see that over time. Then one very useful method is the format method, and the format method is used to combine the values of other data types with strings. Let's look at an example here. So here we have a few variables. We have the cost of an ice bag, and then we have a profit margin, and then we have a number of bags. As such, they are just three variables that we have initialized, and they have different data types. And then we want to output a certain message. We want to say that if a grocery store sells ice bags at a certain rate per bag with a profit margin of a certain percent, then the total profit it makes by selling a certain number of ice bags is such and such. Let's say we want to do this for many different combinations of price, profit margin, and number of bags. What you can do is you can create this string and you can leave out gaps. So wherever you want to fill in a value later on, you can simply put in these braces, and you can see that we have created a string, and the string has a bunch of braces inside it. And now what we can do is on this string, which we have called output template, on the string, we invoke the format method. What I've done here is first I have done some calculation. So I have multiplied the cost of the ice bag, which is some commodity we are selling, with the profit margin, with the number of bags, and that gives us a total profit. Now with the total profit, we want to insert all of these numbers. So these three variables and the total profit, we want to insert it into the output template. So we say output template dot format, and then after saying dot format, we give a list of variables. So these can be variables. These can actually be some expressions. So for instance, here I'm multiplying the profit margin, which is 0.2 by 100 to convert it into a percentage, and then the number of bags and the total profit. And then what happens is when you use the format method, that gives a new string back, and that new string has the variable values inserted inside it. So now you can see it says the grocery store sells a bag at $1.25 per bag with a such and such profit margin, and by selling 500 ice bags, the total profit is $125. So this is something that we will use all the time. Do get used to the format method, just play around with it. Instead of formatting, you can also use the string concatenation operator to achieve this. But you might get issues when you're trying to concatenate or you're trying to add strings with numbers or other data types. And the way to actually solve for that is to take each of these variables which you are doing concatenation with and convert them into a string using the str function. So you see here we get an error here, but here we can use the str function. But the key idea here is that strings have methods. You can call these methods, you can give them some inputs, and often these methods return new results. So as you experiment with these notebooks, try out these string methods and then try out some other string methods as well. Just like other data types, you have the str function, which can take any data type and convert it into a string. Another minor thing is that you can actually compare strings. So here I have declared a string. So you see the single equal to here. This is an assignment operator. So I've declared a string first name with the value John. And then I can compare the first name with another string using the double equal to operator. So the comparison results false with Doe, and the comparison returns true with John. So we have the equality operator, and then we also have the not equal operator, which is in our case first name not equal to Jane, which returns true. That's it about strings. So let's move on to lists. A list in Python is, what you can probably tell, it's an ordered collection of values, and lists can hold values of different data types within them. So you may be familiar with arrays or lists in other languages like C or C++. If you're not, that's fine. But if you are, then you might know that sometimes these lists can only contain a specific type of value. But in Python, there is no such requirement. Lists can contain different types of values as well. So this is how we create a list. So I'm saying fruits equals apple, banana, and cherry. That is a list. And if you check the type of fruits, you will get back the list as the type. Now here is another list. This has a bunch of different kinds of values. It has a number, it has a string, it has the none object, it has 3.14, the value of pi, it has fruits, another list as an element or a member of the list. And it has an expression which resolves to true. So that's nice that lists can contain all of these different things. And then a list can also be empty. And to create an empty list, you just open these brackets with nothing. So to create a list, you need to open a square bracket and close a square bracket. Now, just like strings, you can check how many elements there are in a list using the len function. So the fruits had 3 members, and you can also then take that and use that in string messages using the print function or using the string formatting function and so on. So the other list had 6 members and then the other list had 0. That's how you check the length of a list. Then if you want to access an element that is present inside a list, you need to use the list indexing notation, which basically means the variable name followed by a square bracket followed by an index. So in Python, elements are indexed from 0. So now you have the 0th element, the first element, and the second element. So I like to say 0th element because that makes it easier for me to type these things out. You might call Apple the first element, but if you start thinking of it or just mentally calling it the 0th element, you will make fewer mistakes while accessing specific elements from lists. So here's the 0th element, and here's the first one, and here's the second. One interesting thing about lists is that you can put in any number here, and if you put in a number that is larger than the size of the list or even equal to, because the size of the list is 3, but the only valid indices are 0, 1, and 2. So if you put in a value that is bigger, then Python will give you an index error. And you might expect that if you want to access a list and you're accessing a value that does not exist, you get an error. But if you put in a negative value, so specifically if you put in -1, then this is what you get back. You get back cherry, which seems to be the last element of the list. So lists also support negative indexing. And when you're doing negative indexing, it starts from the end. So this is -1. This is -2, and this is -3. And this is a very useful way when you don't know the length of the list, you still want to access the last element. So you can just put in -1 and get the element back. So that's something that you can try out. But again, if you go too far negative, you're going to get an error. Another thing that you can do is you can also access a whole range of values within a list. So for instance, here I have a list, and then this has 1, 2, 3, 4, 5, 6 elements. You can see here it has 6 elements, and one of the elements itself is another list. And now if I want to access the second element to the 5th element, I can simply put in 2:5, and that's going to give me a sub list of the list. So the result is also going to be a list. So let's just guess what the answer might look like. So we have the 0th element, we have the first element, and then we have the second element. So it starts at this. So you will get back none. This is the third element, 3.14. You will get back this. This is the fourth element, apple, banana, cherry, the fruits list. We should get back this as well. And then this is the 5th element. But here's the key thing: ranges in Python end one step before the last element that is given. So when you say 2 to 5, that actually means the indices 2, 3, and 4 only, not 5. And that is why you get back a list containing the 3 elements, none, 3.14, and the fruits list. You can play around with ranges. There are a few exercises that you should try out. Try setting indices to a range that is higher or lower than the size of the list, like 2 to 10 or 2 to 5 or 2 to 7. Just see what happens. Try leaving out the start index or the end index and see what happens. It works. Can you figure out what it does? Try using ranges with negative indices. So I have left a few blank code cells for you to try this out. Just accessing lists, there are a lot of different powerful ways to do it, and ranges is probably one of the easiest ways that you should get a hang of. So now we've looked at what lists are. We have looked at how to check the length of a list, how to get elements out of a list. But what you can also do is you can modify the list. So lists in Python can be modified. And the way to do it is, if you want to change the element at a particular index, you simply access that index and then use the assignment operator to put in the element. So what that does is now banana gets changed to blueberry. So that's good. Now we are modifying a list. Another way to modify a list is to add something at the end. And to add something at the end, we use the append method. So we use the append method here. Another thing that you can do is you can insert an element at a specific index. This is the 0th position, so this is going to be the first position. So just before this element, something is going to get inserted. So you can see here that banana got inserted before blueberry. And then you can remove a particular element from a list as well. So just try remove as well. And then there is another method called pop. So remove takes a value and removes that value from the list. And then pop takes an index and removes the value at that index. I'll let you try those out. I'll leave those as exercises for you. Then similar to strings, you can check whether a certain element is a part of a list or not. So if we check pineapple in fruits, here's a fruits list. So if we check pineapple in fruits, we get back false. But if we check cherry in fruits, we get back true, because cherry is in fact part of the list. Now note that you have to put in the entire element exactly to match. So if you put in just cherries, or if you just put in CHER share,